So let's start. I did, let's say, somehow called IMU and misalignment flight matrix for our sensor CityMapper, TerraMapper, TerraMapper LM, CityMapper2, TerraMapper2. Because this is often asked by customer. Oh, if I remove the system for the aircraft, what I need to fly, what I need to do. So I put here in the Excel sheet this matrix for, let's say, for our current sensor, 5 different models we have. And then, of course, every time after a new installation, or if I remove the pod from the PV, every time for all the sensor customer, or we need to do adaptive calibration, is obvious. Then, of course, for the cameras and for the Lidar, at every new installation, the first installation in the aircraft, of course, we need to do a misalignment. The same if we remove the system from the aircraft for aircraft inspection or the support or repair or whatever. So we need to do for the Hyperion misalignment, and for the camera, if we replace the IMU, of course, if we remove the IMU, if we replace a shutter in one or more cameras, and then if we remove the cameras, one or more cameras from the pod. So there is, let me check, because the resolution we have. Yeah, okay. So important is if we remove camera, shutter or whatever from an oblique system, so we need to fly the misalignment with a tic-tac-toe pattern. It means with the 12 lines. The only exception is if we have a system that only has nadir camera, like the TerraMapper LN nadir, which has only one LCD 30 camera, or TerraMapper LN, which has 2 nadir cameras. So we don't need to do to fly the tic-tac-toe pattern. Is enough if we fly only the cross. Okay. It is possible, and we will check to prepare a flight plan. Let's say a combined flight plan where we can use for the Hyperion and for the camera Boresight estimation. We can do everything in one go. And also very important for the Hyperion lines, also Hyperion misalignment, everything has to be planned and flown in gate mode, so not gateless mode. Just 2 days ago, we got an incident from API. They moved the CityMapper2 to another plane, and then they went to fly, and they got for the flower lines, they get a lot of back reflection and laser safety, security, whatever. And I told them Pierre to send me the flight plan, even the flow flight plan, and then I realized there were all the lines were planned with non-gate mode, and some of them that were that they have beside wrong SNR, and some of them were for the different project as a calibration area. They have curiously with gate mode planned, but they planned with the maximum multiples in the air. So in this case with 32. So they have about minus 7,000 meters above the hills range measurement. So completely wrong. So I don't know. It was Pierre, because I know usually the flight planner is the Bruno Maleret. I don't know, maybe it's on holiday or whatever. Anyway, always plan in gate mode. So I will hand over to you this matrix, because it was also requested from BU76 and also from Rolf. And additional to this matrix, I prepared two PDF, one for CityMapper terrain mapper, and one for CityMapper2 terrain mapper 2, because as we have two different Hyperion models inside, the parameter to fly, the change slightly change, particularly the scan rate, because CityMapper1, the first generation, you know, they have only 100 hertz scan rate, and the new generation of Hyperion, we have 150, but we will go through. Okay, so these both PDF that are related, I put it in the same folder. I will hand over all this information to you. So there are here calibration flight from CityMapper and for CityMapper terrain mapper 2. We can go quickly. I prepared this small presentation right today. So CityMapper terrain mapper misalignment calibration flight. Most of the information is extracted from the service manual. Curiously, I didn't find this information in the user manual documentation, which I think it should be there, but I have to check it, a new documentation that was sent out shortly. If this information is already included or not, I have to check, but anyway, in our service manual for CityMapper and service manual for CityMapper2, terrain mapper 2, we have all this information. So basically is what we know. So I'm looking for planar surface that are tilted in both directions, large building, warehouse, hangar. The ground level should be well defined, avoid any vegetation, and then it is preferred if there is an area with already a control point, but it's not a must, the control point. Then here are the general parameters. So we fly for Lidar at 2,000 meters. Okay, again, this is extracted mostly from the service manual. There are the basic general parameters, 2,000 meter lines. We will see later if we combine Lidar and cameras, so we can just take 1,600 meters, for instance, and we can fly also for Lidar calibration. We can also use the 1,600 meter lines for Lidar and for cameras at the same time. All the lines should be planned and flown with gated MPA. Check which the maximum number MPA we can allow. It will depend of the terrain height variation. If this is quite flat, then we can probably use 8 or 10 points. If there is a surface or terrain who has some terrain height difference, then we might have to reduce to 3, 4, 5, depends of the area. Try at maximum pulse rate frequency and maximum scan rate, but this will depend of the SNR that we want to achieve. For the image, the minimum required is 60% forward overlap. As more overlap is even better, because there are more surface, common surface for point matching. And speed, of course, as slow as possible to get as high point density as possible. Basically, the misalignment consists in 4 lines, so across, flown in both directions. Each line will be flown once with circle pattern, once with flower pattern, and the same in the cross. You will see flower, circle, flower, circle. And additionally, we have two lines for verification that can be flown either north-south, south-north, or east-west, west east. It doesn't matter. It must just be parallel to one of the direction, and also just one line flown in both directions, and this has to be flown with a circular pattern. And there are the field of view is always 40, and it will change scan rate and pulse rate. Sometimes depend of the terrain again. We cannot achieve exactly this pulse rate frequency, but we should be as close as possible to the pulse rate. Maybe we can get only 415 hertz or something, but we will see in a example. For the combined misalignment flight, as told, this is an oblique system. We need to fly the 12 lines. So 3 lines north, south, south, north, and 3 lines in both direction, east, west, west, east. And this is the tic-tac-toe pattern, and more information more detailed information is in the both PDF that I have prepared. So, do you have questions so far for this first introduction? No?
So do you need for the misalignment flights for the cameras? It's only you don't need 2 lines higher.
This is only if you want to estimate the focal length.
Okay.
If there is no need to estimate focal length, for instance, if you don't change the lens, not the shutter, but the full lens, then you need to fly across at a different level.
Yeah, okay.
But just across. So for misalignment, there are the tic-tac-toe pattern. If you change the lens, you need also to estimate the focal length, and then it will be needed across, I think it's lower.
Yeah.
Lower, but just across, just 4 lines. You don't need for the lens for the focal estimation. You don't need to fly all the 12 lines. And from these 12 lines, we can use north-south line, the middle, center, and east-west for the Lidar estimation. Okay. And one of the parallel, either left or right, or the north or south as verification lines. Yeah. Okay.
So that's why whenever we're doing our flights with the production system, we're doing the different altitude because they're wanting to estimate the focal length. Because it's unusual.
This is to estimate focal length, and this is when we do a full calibration, also Lidar. Lidar full, we are speaking about misalignment.
Yes.
Boresight. What we usually fly here is a full calibration, and for full calibration, we need to fly at 2 different altitudes for Lidar and for cameras.
Okay.
Yeah.
Okay.
So it's the same flight plan, but we need both altitude, and it will be also estimate the focal length. Okay. Focal length.
On the calibration flights, we have the sense and the galvo. Well, it's called sense and galvo.
But this is only needed for full calibration.
But that's only back and forth. I don't think it's across.
Sensitivity and galvo.
Yes.
No, this is back and forth. Yeah. The same line, back and forth. No, you don't need the cross. Yeah. No. There are somehow a single line with different parameters, different settings, just to adjust the galvo on the CFD, the sensitivity of the receiver, of the receiver board. Yeah, but this is only needed for a full calibration, or of course, if you need to replace the full Hyperion module, then you need to fly the sensitivity and galvo lines. And this is the same this is in the service manual. If you replace the laser power board in the Hyperion, you need to fly the galvo lines, because the galvo parameter and setting that are stored in the power board, laser power board. So if you remove the board and you put a new one, you need to fly the galvo line.
Okay.
Yeah. Okay. But this is written in the service manual. Yeah. And if you replace a complete Hyperion like you are doing for Japan, Johnny, when they will get this Hyperion back, then they need to do a full calibration. It means both altitude plus sense line and plus galvo line. Yeah. Okay.
So the range gate's probably still coming. With is that still
Which range gate?
Yeah, we have the range gate. It's like we usually get in the calibration flights. So we see these range gate warnings.
Approaching
Yes,
range gate.
Yes.
Yeah, I mean that there are warnings that are only telling you, okay, pay attention. You are close to the minimum or to the maximum range.
Yeah. Okay.
Yeah. Of course, this is always also uncompromised, because if you plan with, let's say, a high number of pulls in the air, MPA, so your range gate will be closer. As less pulls you plan it, the range gate will be bigger. So you have more buffer, more room to for the range gate to avoid this warning. But on the other side, if you plan with, let's say, less pulls in the air, your point density will be also less. So this is always a compromise. This way, it is preferred to have planar terrain, and with, if possible, as less as possible terrain height difference.
Yeah. Okay.
Yeah. Then you can plan with higher number of pulls in the air, and still have enough range gate.
Yeah.
So less.
This is only for misalignment, because you have to plan with gated mode. Okay.
Yeah. So less pulses means lower density.
Less pulses means lower density, and you have, but you increase the range gate. And higher multiple pulls in the air, you have more points per square meter, but your buffer, your range gate will be smaller.
Okay.
Yes.
Okay.
This is always a dependency. Okay. We will see then when we do the practical session. Okay, everything clear for this point?
Let's see.
Okay, let's continue. The next one, the matrix. Okay, we will come back to them. Okay, let me, this is quite a big presentation. I won't go through because I already extracted the most important thing. I want to show you a general knowledge, and then we will go to the practical session. This document, best practices for planning and for, wait a moment. This document is in Teams. This is in Teams, and basically there is an explanation. This document will be also handed over to the customer, also when we do the training. And basically here is an explanation, step by step, about Mission Pro, Flight Pro version dependency, productivity and pulse rate frequency, sensitivity and signal to noise ratio, sensitivity and threshold discriminator settings, surface repetibility and SNR. If we use pore glass or not, I don't know, but my recommendation is with Lidar, don't use pore glass, because besides you lose, usually the pore glass, they are not coated on the plane in most of them. And the impact is that you get a very high back reflection, which even can damage the receiver, APD. But beside this, if you use a pore glass, every time the laser ray goes through the surface of the glass, it means it has to go out in the upper surface, out the lower, and then comes the return. If the glass is not coated, you can lose up to almost 20% of laser power. So if you are flying high, even you have 100% laser power, this most probably beside back reflection, you will get dropouts. So This way, our recommendation is to not use port glass, or if the necessary, use a port glass who is coated on both surface with appropriate wavelength that match the laser wavelengths with this 64 nanometers. Yes.
If there would be a little gap between the aircraft floor and the PAV, and in case you're using a port glass, is this then eye safe or not?
Yeah, this is always usually it should be eye safe, because you are not sitting just on the top of the sensor. So even you are sitting beside or in the front or behind, we have never seen or we never heard about eye safety issues. The issue are more, the back reflection are more related, because the back reflection comes usually back in the sensor and goes directly to the receiver board, to the APD. And we have seen, for instance, ICGC in the new plane, they put an ALS 50 they had. They put it in the Beechcraft 350, and then they went to fly. And they did fly somewhere in the Pyrenees with 100% laser power. And then after, let's say, a couple of kilometers, there were no more returns. So they physically burn with the back reflection from glass, the APD receiver board. Yeah. This way, we don't recommend to use port glass, or in case you need to use a coated port glass with the appropriate wavelength. Yeah. But for the safety for the people inside, until now we never heard something about this.
And second question, also with eye safety, but in this case for functionality of LightPro, for instance, if you get these bad reflections, as far I understood, if you fly too low, the laser will switch off with some eye safety threshold. So if you have the back reflection from the port glass, will happen the same thing here?
Yeah, if the back reflection are such strong, then the laser, so the receiver will interpret, oh, you are flying too close to the terrain, and then the shutter will close as an eye safety measure. Yes, this is the same here. Yes.
And how it could happen that the receiver was burned? This safety function did not work at the time?
Yeah, sometimes, usually the shutter should close before it can be dangerous. But in the case, we have already some cases also with CityMapper that it happens first that the receiver board was burned before the shutter was closed.
I see.
Yeah.
Gracias.
So always, yeah, this always so. If they need to fly with the port glass because they want to fly quite high, then the only let's say recommendation is to use a port glass with is coated on both sides. If not, with a normal port glass, like the most of the almost all customer have, then so I would recommend to avoid to fly any type of laser with this type of port glass, because you can damage more than the productivity you will get if you damage your sensor all the time. We have a customer in Peru, Horizon Peru. I think in about 1 year they burn already three receivers.
They don't learn.
Yeah, looks like not. I don't know.
But this is only for terrain mapper, or do you ever?
No, it's the same for ALS and terrain mapper and CityMapper.
No, I mean you've ever seen an installation with such a huge port glass that you can use obliques from the CityMapper?
Sorry, can you repeat, Albi?
Did you ever see such a huge port glass that you can use a CityMapper in pressurized aircraft?
Mm-hmm.
Not from my side.
No, I would avoid to use this to fly with the CityMapper, Terrain Mapper, or ALS.
I don't think there's any
any
port glass
Lidar.
big enough, LB, in an aircraft. I've never seen one close that would
Yeah.
allow it.
Yeah, that's
Yep.
what I thought.
We have. I can grab. We have also a technical notes from Ron about which type of port glass could be used, and then there are all the specifications. So if you know in advance as a customer, try to fly with pressurized aircraft, and please give them this technical notes, and if he want to fly, it's his responsibility. As long he don't install port glass with a specification. Yeah. Okay. Okay, then it's noise filtering and point density variation. This is also related more for post-processing. Close range noise and suppression. There are the new functionality that is only applicable for Hyperion 2 Plus, so the newest generation of laser. Because the Hyperion 2 and the Hyperion 1, there is from the hardware side is not possible to use this close range noise and suppression. Field of view, close range, flying height, so what is related, and then a summary of the planning recommendations. So we will focus on the first part, and the first is explanation of all these topics. So that is very important that this document will be handed over to the customer even before you install the system, so he's aware what to take into account. Mission plan settings, productivity. This is a explanation of the index, and what is important for us is this table we have here. This table, this general settings, the values, additional SNR for uncoated glass with. You see there is a number there, which values in which condition or exception can be used. Receiver threshold. So we will go through this parameter, and then also for different type of project, if there is power line, city modeling, at different altitude, and if you know the building heights, general survey, general purpose, and wide areas. So there are typical flight altitude and which setting should be or are recommended to use for flight planning and for flying. And here is continuing more with different application. So always I recommend you when you prepare a flight plan or when you give the training at customer, this table is for me, let's say 80% of the case, the parameter that you can choose from this table can be used 80% of the cases. Okay, and at the end there are also some table. Here are some explanation to this different paragraphs, and this part is more for the workflow guys, for the noise filtering and for the XMAP and whatever. So they have also to fix some parameter in XMAP to avoid noise and so on, like this one, these cases, fine tuning, over tuning, whatever. As told, this document is in Teams. I can grab then either the document, send it to you, or the link, the Teams link, so you can download it or print it or whatever. Okay, here is this technical note about the use of aircraft windows. Okay, there is also place because from time to time Ron do some update, so always grab him Teams and look for the latest. This is not very new, from 2019. Probably it's a newer one. I have to check, but basically is also a subject explanation, the background, the signal loss that you will lose depending if it's coated or uncoated glass. What can happen? Damage to the laser due to back reflection in the laser optic, overload receiver. We have seen inconsistency in the integrity of the range data. So therefore, all sensor manufacturers, including Leica, recommend to use a glass that is anti-reflection coated on both sides. If a port glass is to be employed in the aircraft. And here the design of the optical windows and the specification of the glass, quality, grade, and the coating required. So high efficiency anti-reflection coating. And I think the Cosmo Optic is one of, there are not too much optical glass manufacturer for pressurized aircraft. One of the most known is the Cosmo Optic. It's in the US or in Canada. Here is some diagraph about wavelength and white lines. So there are alternative coatings, different coatings that can be used. Which one not? As told, this document is placed in Teams with all the explanation, and this document is also interesting if you know customer plan to fly with port glass. Always hand over this document so he is aware. What can happen and what kind of glass he should use. And in case of any question, then the best is to contact directly Ron. Okay, so we have Mission Pro, and then we can prepare a new flight plan. Next. Okay. Let's say which type of sensor do you want? Let's say CityMapper2, for instance. Okay. CityMapper2 S is maybe the standard. Yeah. Here we should check always for the latest hardware configuration or calibration file. I think we have already, or we should have version 3, but let me check. If not, when you install Mission Pro, in the Mission Pro installation folder, hey, it takes long, huh? In the Mission Pro installation folder, there are always the latest XML file. So Mission Pro installation is always in program files, Leica Geosystems, Mission Pro presets, and here I look always what is the latest mission Hyperion. Yeah, you see. The latest with this Mission Pro version is already a new XML file. It's Hyperion 2 plus version 3. So I select this one, the latest one. Oh, this was wrong. Oh, okay, I can select later. Next. Let's take our PC aircraft. Okay, so here I can have an overview, and the first I will do is to check the XML file because I think I select the wrong one. You see, I have still the old one, version 2. So I want this one, version 3. Yes, yes. Compute. It's maybe the same version. It didn't. They get a new version, but they didn't change the name.
Yeah, maybe if you go out and in.
No, I don't think so. Okay, I will check later. So let's do for now with this version. Okay, here there are the general parameters, the sensor, the aircraft. The aircraft is important to have one defined, particularly for the Lidar project on this, because you need to set up here navigation tolerances. These navigation tolerances are particularly important for the gated flight planning, because you should have always try to have in the range gate above hills and below valleys, you should have at least the same value as you have in your aircraft navigation tolerance. If this is more, it's even better. So here is 30 meters in tolerance across altitude, which is more or less okay for the Pilatus. Usually we have less, but and also if you put here some values, you can at the end, in the case of project fly, you can estimate cost for this project. But you need to select the aircraft, and you need to fill out at least cost per minute, the time to IP, bank angle, and all the parameters. If you want the cost estimation, you should also fill out this maximum lift time and estimated transit time to the project area from the airport. Okay. Coordinate system, you can choose whatever you need, but usually geographic. And okay, let's go through flight plan parameters. For the moment, so we want to set up with the manual settings. We will plan for manual setting, 40 degrees field of view. Terrain reference, we don't know, because we still don't have accepted the flight plan. We still don't know where our line will be. Fly high above. If we want to do a combined flight plan for LiDAR and for cameras, then I would say we will go to 1,600 meters. let's say 110. And here, very important, uncheck gateless. This is very important. And the rest, okay, I let open for now. I will, for the moment, check auto adjust to get the maximum possible point density. Okay, then next, accuracy settings. Here, we select the signal to noise ratio, and remember for circular line, we use 12. For flower, we use 7.1. Okay, this is describe it in the document. We don't choose for this automatic SNR maximization, but we have to check is the threshold discriminator. That is correct. Is 125. This is correct for our Hyperion 2. And more. This is the navigation tolerance taken over from the aircraft. Okay. Next here, we have only to check that we have the preferred maximum number per returns is 15. This is the fall. Image sensor, we can here more or less estimate which GSD we will have. So it will choose here 1600. So probably we can get maybe 5.2. Yeah, even more. So, no, 5.4. This is the estimation of the GSD that we will get at 1600 meters. Okay. What we can check here is also with this altitude and with this speed, we can check here also the minimum cycle time that we have for the 6 cameras. This is 0.9 second frame rate cycle time between shot. And with this initial parameter, we are required for 18 seconds. So we are more than enough in tolerance. So we should not have any issues. Of course, we didn't choose yet the overlap. And hardware configuration, we let it know for this. Okay. So I say compute. Don't worry about this warning because this is the initial plan. Okay. Then we go to elevation advanced. We are still in flight plan level. We are still not working on AOI or in flight line level. In AOI and flight plan level, the warning has to be taken in account, and if possible, we should correct this. So use the DTM, of course. Allow different flying heights, yes, and consider terrain outside. I would always check. What we need is a long track. We told is minimum 60%, right? 60% for forward overlap for the cameras. I would say that to be on the safe side, 65. So to have a little bit more room. AOI is nothing because we didn't have any AOI, and even data frame, this is only used in the old film cameras like RMK and RC30. So, okay. Then we have now our globe windows here. Okay, and now next step is to choose our calibration area. So let's say it can be some area here, maybe. We can check here what is this area, more or less, if there is not too much terrain height difference. Looks like quite okay. So now we have the first option is to directly draw a line. We go to this tool, draw a line, and let's. Sorry. This is not a good. Place for the misalignment.
Because of the water.
No, because we don't have buildings with surface. So we need to look somewhere for a city.
Yeah.
Let me check. Maybe all. Yeah, it could be. Yeah, it's not too big. East west is okay, but northeast is probably too short for the line. Let me check. If we go here. Yeah, it's 3 kilometers. So we should check for a little bit bigger city. Check. This Memmingen is a big one.
How long does the run need to be, ideally, Paco?
Sorry?
How long does the run need to be, ideally?
How long?
Yeah.
Oh, I would say half an hour.
No, but like line length.
How long the line? As far I remember, for oblique camera, it should be at least 10 kilometers.
Okay.
For only nadir cameras like CityMapper2 or CityMapper LN is more than enough, 6-7 kilometers.
Okay.
Around 10 kilometers should be. So we need to look more or less. I mean, if this is 9 kilometers, also okay. This is too short. So let's look for a different. Yeah, let's to Weingarten. We do in Weingarten, right?
Yeah.
And maybe, yeah, Weingarten is not bad. Yeah, okay. It's not quite long. Okay, let's do here. In this document, in this PDF document, this is also the line length is also written there.
Okay.
What should be approximately, so
Yeah.
it must be not exact. Okay, so I have my first line here. Let's say I will maybe move a little bit the line. I will move the line a little bit to the to the left. Maybe. Okay, this computation. Okay, so here in the line properties, we can also see now how long is our line. This resolution is not the best, huh? Hey, why I didn't get? I cannot see all my. I cannot see the resolution for the big screen is okay. I will look at a different way. I will look here. Length of the line 8.8 kilometers, so is much better. Okay, so first I will do is I will set up my first line on the line level. So properties, because now I know now in aeroplane, the terrain height difference I have, you see?
Yeah.
The rest of the parameter for now remains gateless. And what we have to check now, if I do compute, I will for sure get a warning. So minimum flying height is less than the minimum sensor range, reduce field of view, or disable MPA. It's not correctly disabled, it's reduced MPA. So field of view, we will not change. It remained 40, and this warning comes from here. Range margin above hills, you see, minus 4,000 meters, and below plus 4,000 meters. So that cannot be. In gate mode, you need to have always positive numbers. So to avoid this, so we need to go down with the pulse rate, with the pulse in the air. Let's say go to 10, enter, and still get the same warning, but I cannot check how far I want. Okay, still 385 meters, so I go back 5. Okay, no more warnings, but maybe I can increase the point density. So now I have a buffer above hills of more than 100 meters. And below valley, I still have more than 30 meters. That is the navigation tolerance. So maybe I can get one more. Yes, and I think this is quite balanced. Above hills, below valley. It means the pilot will have a range of almost 60 meters to fly higher, or 40 meters to fly lower, without start to get in this range gate warnings.
Okay.
If I try one more, you will see probably I will get the message again.
Yeah.
You see,
Yeah.
it's only 21 meters, the hilltop. I have still positive number, but my buffer is less than the navigation tolerances,
Which is
19.
Yeah, yeah, okay.
So I prefer to have, and the point density, the lowest is about 5.7 point. And if I go to 6, I still have almost 5 point density, but my range margin are much better compensated. Okay, so this line is for me okay. I go and review everything. SNR 12, I will choose a circle line. Threshold, it's okay. And the rest, it should be okay. Okay. Good, then I give okay. And let me check. Yes, now it's better. So you see Mission Pro, right? Okay, so let's go through again. This was 6.
I'll go on my laptop quickly.
Yeah.
Did it sort it?
Yes, no, I can.
No,
I
now
have.
you can
No,
click it.
yeah, no, I can. So let me quickly check. Yeah, this it's okay. All the setting remains 12. Yeah, okay. Okay. Okay, now one thing I have to check, which is the pattern, the circle pattern, which it's okay. And now we need to check with combined flight for CityMapper. I have to check here which parameter I need here. SNF, I have to check SNF is more than enough. Hyperion, successful. Okay, so let's start with circle line, and I need about 400, around 402 kilohertz. Okay, I need to change, and about 76 hertz scan rate. So I have MPA error, so I have here, I have to reduce here. Five is maybe too much. Yeah, so 4. Okay, what is the maximum I can get here? Yeah, this is the maximum I can get here. So this is because this we have almost 150 meters difference, but I have a good buffer for the gate mode. I'm a little bit below what I expect, because 400 kilohertz I can get it if my turn height difference is smaller, but it's okay. I'm quite happy with these parameters. Yeah. Okay. Then compute. Okay. And then I will give a name here to my line. I will say it was, I don't remember, it was north-south or south-north. Let's say north-south and C from circle. And resolution, and let's say the overlap for the camera is 65, which is okay. Let me check the line direction. Is north-south, yeah. Is north-south. Okay, so compute okay. So I have my first line. Now the second point is I duplicate this line and change the line direction, and then I have the opposite and change the name. Right click, duplicate, change flight direction, and change the name and the pattern. Now go to properties, south north. Sorry, forward. It must be forward. And I go here, change to flower, and for flower is the scan rate should be maximum under 50, and let's see what happens. Yeah, it's not possible. So 4. Okay. And I need to change, remember, SNR for flower 7.1. And then probably I can increase now a little bit. Maybe I can increase a little bit. No. I will check. No, this doesn't allow me to increase the pulse in the air. Okay, and SNR, I have the target and the computed. Okay, then it's okay, compute okay. So now I have my 2 lines, and then I can start to check here if this is correct. Flight line level. So computation is okay. Circle, flower, north-south, south-north, length is the same. SNR is correct. Scan rate is correct. What is also important is automatic receiver threshold fair, and gateless MPA is false, so it's gate mode. Okay, so now I have my first 2 lines. So the next is to we can duplicate again this line, and this line I will change the direction in about 90 degrees. Yes, 90 degrees. So where is this? Where is the to change the line direction? Okay, it seems to not to be here, because I remember in earlier Mission Pro version we could uncheck here the line direction, and we could put the number directly. So it seems it's not possible. So what I will do is I will delete, and then I will draw manually 1 line, and then I can change the line direction, or more or less in the middle. So let's see how long is this line. No, it's about 9 kilometers. It's okay. And direction is yeah, is 90 degrees, so almost 90 degrees to 180. It's okay. Okay, so this line line direction. So this line is west-east. And I don't remember if it was flower or circle. I will check later. Circle resolution. This is circle, correct. Settings 12. This is correct. It should be around 6. No, it's too much. 5. Yeah, I have good here. And it was 76. Okay, let me check. SNR is okay. Range margin are okay. 400. Now here I have a little bit more. Don't worry about, and the rest is okay. Okay, okay. So I have my 3rd line. Okay, west-east, circle is correct, west-east, 12 SNR, and the rest is okay. So then let's go to the 4th line, duplicate again. Change flight direction, or change the name. That must be flower. Here is 150 and 7.1. And that's it. So I have MPA warning. Yeah. That must be 4. Yeah, now it's okay. SNL is okay. And yeah, this is okay. And the rest should be fine. Yeah. I prefer to double check everything. Okay. As with circle. I need to change now the line direction. Okay, now I should have my 4 lines. Check flower, circle, circle, flower. Line direction is correct. And the 50, 71, 71. Okay. So now next is to work with I hide lines and just select one north south, for instance, to show. And then I duplicate the line. You have to take in account if you choose add parallel lines, this option to add a parallel lines either to the left or to the right. The problem is that this new line will get an AOI name. So I prefer to duplicate the line. So now I have 2 lines. I changed the name to know that I will work in the verification line. For instance, verification 01. Okay. And then what I do is I hide this line for the moment, and also I will hide all the oblique sensor. I will keep only the nadir sensor, and then what I do is I'm going to measure how much is the coverage here. So the SWAT width, sorry. This is about 1,146 meters. So I will now shift or move this this line of about yeah, about 700 no 400 meters. Wait a moment. Let's do no 717. It's about 300 meters. Okay. Okay, I will show this line. And then I will enter in the editing. And I click on this line. And then I move this line about 400 meters. Okay. So then I have more than enough the coverage of both lines. More than 60%. So if you have more than 60%, it's even better. Okay, then I have this line. I duplicate. I change the direction. I changed the name. And that should be okay. Okay. So now I have all my 6 lines. That will be an example for Lidar. Show. So I have my 6 line here, circle, and everything is fine, in my opinion. Okay, that will be a typical misalignment for the Lidar. Now, if we want to combine for the Lidar and camera, let's check the parameters for the MFC Boresight.
There is a minor thing, I guess.
Sorry?
You have 3 circles, or 3 Charlies and 1 Foxtrot. So I think one line has
I
one
have
name.
4 Charlies. I need to have 4 Charlies. Ah, okay. I have 4 Charlies.
And only 1 flower.
Sorry?
I think I understood one way you fly circle and the way back you fly flower.
Correct.
And the west-east and east-west, they are both underscore Charlie.
Ah, this is about the name. Sorry. Yeah, you are right. You are right. This is the name. Because because here the scan pattern was correct. What was not correct, it was the name. Yeah. Yeah, you are right. Yeah. So circle, flower, and both verification circle. Okay, it's what we can do is if we fly, let's do Boresight oblique calibration. For the Boresight oblique calibration, let's do the following. I duplicate the flight plan, make the flight plan active. Then the 2 verification line, I don't need it because I will take one of the parallel lines for the tic-tac-toe pattern. So I will say these both lines I can delete. Okay. And now I need line spacing must be 1,600 meters. Okay, in this case, I go again. I take the central line. And I duplicate this line. And then I will move this line. Let's say more or less here. And then I will check distance around 1,600 meters. It's too much. A little bit less, editing mode.
And this task you also cannot do with add parallel line, 1,600 meters offset. Has it to
Yeah, but you will get AOI. I can show you later what is the difference. So for me, it's more clear this way. You can do. I know what you mean. So what you mean is this here. I will show you what happens. Now, then I put here add parallel lines. Let's say to the right, and then edit this, edit settings. And spacing, regular spacing, 1600 meters. Let's see what happens, but in my opinion, that should give like an AOI. Yeah, it's okay. You see, instead of parallel line, I got these two lines in an AOI. I mean, you can work this way, and this should be 1600 meters. Yeah, thousands. I mean, you can work this way. It's up to you. Would you prefer to do it? In this case, we can add parallel lines to the left, and then you can rename to the left the same. Okay, it was not checked. Okay. Yeah.
And what is the disadvantage to have an extra AOI?
Disadvantage?
Disadvantage.
No. There is no disadvantage. The only thing you have to rename much more lines. And the layout for me is more clear, like a layout like this one, line by line with each line's name. But there is no disadvantage. So you can keep this like this. So the only thing is that we have now one line, two lines, three lines, and this line. This now I have four lines instead of three lines. I have four lines. So I think one of this line. I think this line is we can delete.
Does it appear to me that parallel lines are shorter than the others?
Yeah, this is also strange. Yeah? Because I don't know why. Okay, let's go back. This is the center line. Okay, let's say this is the original one. Yeah, this is also, I also noticed this one. Okay, let's delete this one. And delete this one. So, and this line is so let's see. So parallel lines, let's say to the right, one line, it's okay. Regular space, okay. Then compute, okay. Yeah, this normal. Wait, wait. This is probably because there are not lines, there are probably I don't understand why I got 3 lines more. If I have only 1 line, add parallel lines. This is just 1 to the right. Let's write to the left. Constant spacing. Why they add 3 lines more? I don't know why they add 3 lines more. Don't understand. I think this is a bug in the software. Should not be. Okay, let me try a different thing. Don't know, I have only 1 line. But you see, this is as AOI. This is the shit I don't like. So delete this here. So I just have 1 line and nothing more. Okay, so parallel lines. Just 1 line to the right with constant spacing 1600 meters. Okay. So it must be done 1 by 1. This is strange. Because if I select now, this is the original line. If I select now, add parallel line to the left, or maybe this one. Let's hide this one. To the left. 1600 meters is the same. To the left, and it put me to the right. I don't understand. They put me on to the right. You see, this is this option without parallel line. I don't like it because I don't know what I am doing here. Now I select 1 line and I put 1 to the left, 1 to the right, and I have 2 lines on the same location. So for me, this is inconvenient. So I prefer to do the other way. Delete this flight plan and continue with my flight plan. So I have so I will circle 2. And this is circle 1 for combiner flight. Okay, so we have 1, 2. Now I need to. Sorry, 1, 2. No, that will be 3. That will be 3. So. And now I duplicate this one. Change direction. Change the name. This will be flower line 4. I can try here to get maybe 1 MPa more, maybe. No. Okay. This is flower 4, computer clean. Okay. So I will rename this to flower 02. Or 2. Okay. So now I have this one again, this line. I will duplicate. That will be north-south 5. Okay, and then I will move this line. A little bit more. Let's measure. It's too much. A little bit less than we have it. So basically is to move and this is line 3. Yeah, it's also a little bit too much. Come on. So no, it should be more or less. We have to play a little bit until we have more or less 1600, more or less, approximately. Okay. And this one. So we need to duplicate. Change direction. Change the name and the pattern. Okay, check here. Yeah, this is okay. Maybe I can try one more. No. It's an app. It's okay. Why they have not? Why they have 1, 2, 4, 6, 8 lines? I have 8 lines. 2, 4. What I see here, 2 lines here. Okay, so next is to duplicate this one. Let's hide. Let's duplicate this one. Show. Show. Here we have, we have here on the right side we have some mountains, and we see the difference in the a little bit more. Okay, this will be list as number 7. And okay, let's check. Circle 12. Yeah, it's okay. So I duplicate this one. Change direction. Change the name. That will be flower 8. Change the pattern. And SNR. Here we have too much. Yeah, minus. This is because the mountains. Yeah, no, it's okay. Okay, and now we can hide this one. show this one. Hide. Duplicate. That will be 910. That should be flower. Is flower, yeah. 7.1. Okay, no, duplicate. Change direction. Change the name and the pattern. Let's see if I can get a little bit more point density. Yeah, I get it. Good. Okay, and now I need to rename this one to be circular 11. And this one, flower 12. So, and now I have my flight plan show. So I have my, oh, I forget something. One, two, three, four. Oh, I need to delete this one. That must be flower, right? One line was somehow duplicated, but at a different location. Okay. So wait, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 9, 10, and 11, 12 are the same. So I need to remove this 2, 1. Okay, so I will let more or less here. I can. So it will be 9. So check if this is correct. This circle. Circle. Okay. And 9 must be flower. It should be flower. And this should be flower. Okay, not should be okay. So I have now 1, 2 is in the center. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so let me check now all the lines and let's start. So let's check this circle, flower, circle, flower, circle, circle, flower, circle, flower, 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 circle. So we have 1, 2, 3, 4, 5, 6 circle, 1, 2, 3, 4, 5, 6 flower. So now let's check line sequence. 1, 2, then 3. Let's go up. 3, 4 is flower. Then we go to 5, 6. Okay, so I will do update now. So we have 1, 2, 3, 4, 5 circle flower, circle flower. Okay, now if we finish 6, then let's say 7. Yeah, next to 7. Oops, 7, 8, 9, 10, maybe we can put this here. 10, 9. So circle flower, circle flower, circle flower, circle flower, circle flower. Okay, there's more or less the sequence. So let's see if this is true. 181 north, south, south, north, south. this is wrong. North-south, it's okay. South-north. North-south. That should be south-north. Okay. North-south, 5th, and the 6th, south-north. I need to change the name. Okay, this is west-east, is okay. And this is west-east. No, sorry. Okay. West-east. This is west-east, and this is west-east. Okay. Yeah, that should be okay now. Yeah, that looks like this is correct one, but I need to change here. Flower. I need to change here 150. Just a moment. I need my charger. Just a moment. Okay, so let's review. Circles is correct. The circle is correct. This one we need to change the scan rate. It must be 150. Okay, and yes, quickly review all the parameter. Okay. Okay. Circle, flower, we need to change also this one. Circle, flower. So this one. So, and let's check. It should be more or less okay. So it's match. The naming with the pattern, direction match. Scan rate with 12 should match. 7 1s. 7 1 12 7 1. Okay. And here MPA gate files. Okay. So for me, that will be the combined tic-tac-toe flight plan for MFC and for Hyperion 2 Plus. We can change here the name. Okay.
One question.
And this will be Hyperion 2 Plus misalignment. Okay, so if you have any question, you let
Yes,
me
I
know.
do. Since this is kind of complicated and a lot of effort to make such a flight plan, is it possible that you can copy this and move to another part of the world?
To copy this flight plan?
Yeah, and move it to another country, for instance.
Yes, it will be possible. I would have probably to refine here a little bit the distance between lines to make a little bit more accurate. But then what you can do is yes, you can check, for instance, what you can do is the following. You can go here to the center of the flight plan. Let's see here with a pointer, and then you look on the coordinate bar here. You check the coordinate bar, and you notate the coordinate bar, and then this is your starting point. Let's say the center of your project, and then what you can do is you can move the flight plan. And then you can give here, this is a relative, if you want, let's say, to move, let's say, I don't know, maybe somewhere, let's say let me quickly, maybe here, for instance, you want the center of your flight plan here, then you annotate the coordinates from the coordinates bar, and then what you have to let's say, subtract from the original point to the point where you want to have your central point or your flight plan with this tool. For instance, let me quickly check. I will do a duplicate. Always, I recommend you, before you do anything, make a duplicate so you have all the time your original flight plan back. Okay, so let me check optimal zoom. This is my flight plan, and then I say okay. Then I want to move my flight plan by 3 degrees in east and 5 degrees in north.
Does it recalculate GSD?
I'm not
Okay.
sure.
to keep it in spec, or does it
I
just?
have to check. And then optimal zoom. So now we have our, now I think it moves all the parameters together.
Okay.
So you see, it moves complete flight plan. Then if, of course, if the terrain is not the same, then let's check, for instance, one line and see what parameter we get. Oh, we have here a lot more. You see, we have here the terrain difference is higher. You see, and I have here the range margin in negative. Can you see it? Can you see this value?
Yes.
Minus 24, you see? So it means you have to recompute your lines in aeroplane. So here in this case will be 3, and then it's okay. But this is the way to do it. And then okay. This is the way to move the complete flight plan. And then, of course, as the terrain changes, then you need to go through your lines. Let's check another one, and make sure that the parameter still fits with your needs. Here I have minus 84. So because you see here, the terrain height difference is more than 300 meters. And in the original flight plan, there was around 150 meters. So this way